We are on the site to build the Cape Town bus lane, BRT bus lanes, and this is one of about 17 different projects involved with building these bus lanes. At the moment, as you can see, they've got a couple of vehicles lined up to pour the concrete for the wearing surface of the structure, the pavement structure, which the bus actually drives on. So they've placed the steel and they're pouring concrete. Some pavements last longer than others, and the city in particular wanted a pavement that would last for a long time, in this case 40 years. And they wanted very little maintenance. Maintenance, I mean ongoing repair work to the pavement. And typically, if you build an asphalt pavement, you have a fair amount of maintenance over its 20, 30, 40 year lifetime, even to the point of needing a rebuild at some stage. So you can imagine that there could be quite a high cost initially with maintenance and a rebuild after say 15, 20 years to last say 40 years. With concrete, you can design a pavement that can last 40 years with very little maintenance. In this particular case, we opted for a concrete pavement with no man-made joints, naturally occurring joints, which the concrete itself decides where to put them based on its shrinkage and the steel we put in. It's a high cost option, even though long term it might be a lower cost than what you'd normally go for if say you use asphalt, but still people have a hard time spending big money up front. So this is a high-tech solution to heavy loading. We are sitting what's in a partially constructed concrete BRT lane. What you see is part of the road pavement. Most of the pavement structure you can't see, it's below me. You've got at least 3 or 4 layers below this, which is your subgrade. It's typically a sandy material. Then you have a lower selected, which is a gravel, an upper selected, which is a gravel layer. Then you have your subbase. You can see now the subbase. This is a crushed stone stabilized with sand and cement. It's allowed to cure, so it's hard, about 150 or 200 thick. Then you have space for your concrete bus lane, and that's about, in this case, about 200 thick or 190 thick. Now, the concrete will be poured more or less here. This is your reinforcing steel. Its purpose isn't to make the concrete stronger, it's to keep the naturally occurring jointed panels together. Normally in concrete, this steel is lowered down, which gives you tensile strength at the bottom of your layer. This steel is typically in the center of this layer to hold the natural panels together. So your cracked joints that occur naturally don't open up, and hence you have low maintenance with time. So those joints are kept tight. That's the function of the steel. They're pouring concrete, and how it's done is the truck is close to the pour site. It dumps the concrete on top of the subbase and the steel. Then the guys actually make sure the concrete is well pushed up against the vibrating rail to make sure that there's no dips or gaps. So it's a hand-intensive operation where they push the concrete against this rail. Then the rail actually vibrates to almost keep it uniform in its depth, keep air bubbles out. Occasionally they'll have a vibrating machine here, which has a strange shape, and they'll poke this machine into the concrete to help it to settle and compact naturally. Then once that's evenly spread, they will use a floating beam with a nice flat pedal to make the surface smooth. If you see there behind the rough area, it's quite smooth. That's the first stage in preparing the surface. Once that's slightly hard, they'll rake it with a broom to get a nice rough texture. and then they'll spray it with a curing compound so that the moisture stays in and it doesn't dry too quickly.